In this lesson, we're going to learn about the types of memory in Solidity. We'll see that not all memory is created equal, especially in terms of gas fees. We'll go through the three types of memory in Solidity, which are storage, memory, and stack. Stack memory is 256 bits by 1024 elements. Memory is volatile memory, it is byte addressing and it's linear. And account memory, or storage, is persistent memory, and it's 256 bits by 256 bits, and it functions as a key value store. Let's go through them one by one. Storage holds state variables that remain in the contract. The analogy here is that the blockchain is a database that holds storage data. This data persists across all executions of the smart contract. In other words, it is not volatile. It is a key value store that maps 256-bit words to 256-bit words. And remember, storage here is costly. It uses lots of gas because it is written permanently to the blockchain. Next is memory. This is a byte array that exists only during the function call. Every message call starts with cleared memory. Memory is volatile data and is not recorded on the blockchain, so it is much cheaper than storage. Memory can be thought of as RAM, used to store short-lived data that spans function calls. Memory can be used for every non-permanent data. Finally, we have the stack. The stack holds small local variables. It has a maximum size of 1024 elements and contains words of 256 bits. That means the maximum size of the stack is 1024 times 256 bits. If you run out of the stack, contract execution will fail. The EVM provides many opcodes to change stack directly, such as pop, push, duplicate, and swap. The stack is an internal place where temporary variables are stored in 32-bit slots and is usually used for value types. So, a quick summary. Storage versus memory. Storage stores data between function calls, whereas memory stores data temporarily. Storage is accessible in each run of the smart contract, whereas memory gets erased as soon as the contract execution finishes. Storage causes high gas fees, whereas memory is cheap, and storage holds array, state, and structure local variables, whereas memory holds function arguments. Let's look at an example. In this example, the smart contract's state struct variable, lottery number, is kept in storage, and this data will persist in between function calls. An example of memory. In this example, the num variable is stored temporarily and locally in memory and will be released as soon as the function call is completed.